In this example, we are told that out of 1,000 people in Nigeria, 50 died of a road accident. Find the probability that a person will die of road accidents. Now, if you look at this particular example, you agree with me that this is experimental. How is it experimental? Maybe the Federal Road Safety are carrying out some records or statistics. They were counting them. Maybe one person died, they look at the cause. Another person died, they look at the cause of the death. Another person died, they looked at the cause of the death. Now, they did this for 1,000 people. So they recorded 1,000 deaths. So 1,000 deaths were recorded. Then out of this 1,000 deaths, they find that 50 of the deaths were caused by road accidents. You see, this is an experiment. So you see that this 50 is a kind of your success set. This is your success set. Then this 1,000 is your universal set. Okay. Now, the question says, find the probability that the person will die of road accidents. So what it means is that you use what you have observed previously to predict what will happen. So this is experiment in that form. So you use the observations to predict what will happen in the future. So that kind of probability is experimental. So now, if you are looking at your success set to be the deaths by road accidents, you are looking at the deaths by road accidents, then your mu, your set mu, for instance, becomes the number of deaths, the deaths. That is, you are looking at all the deaths. You are not interested whether it was caused by road accident or any other cause. So if you are looking at the probability of this X happening, that is the probability of somebody dying of road accident, it becomes how many people died of road accident. That is how many elements are in this set. There are 50 of them. So you look at your n of S over the n of your mu. So this will give you the number of elements in this set here is 50. That is, death caused by road accidents is 50. So this is 50 over the deaths. All the deaths. How many deaths are here? 1,000. They recorded 1,000 deaths. So now, 1,000. This is 5 over 100. This is 1 over 20. That's what it has. So it has this to be 1 over 20. So you can leave it in fraction. So we can say now the probability of somebody dying of road accident is 1 over 20. And that's what we expected to get. But we pray that nobody is dying. We're only giving an illustration. In this example, we are told that out of every 3,000 cars, 500 develop fault within 6 months of purchase. What is the probability of buying a car which will not, so here, which will not develop fault within 6 months? So this is also experimental because they have been checking cars, and out of these 3,000 cars they have checked, they found out that within 6 months, 500 of them will develop fault. So, but here, the probability we are looking for is the probability that it will not develop fault in 6 months. So now, let's look at the faulty cars. So the faulty cars, those cars that develop fault in 60 months, we are told there are 500. Then, that means how many will not develop? The non-faulty ones, the non-faulty, that are those ones that will not develop fault. We are looking at the non-faulty cars. What would they give us? We have total number of cars in consideration is 3,000. And within 6 months, 500 will develop fault. So how many will not develop fault? It becomes 3,000 minus 500. So it means that 2,500 cars will not develop a fault. So what we are looking for, the probability we are looking for, is for those ones that will not develop a fault. So the probability, so if you want, you can say your success set S. That is, the success set is the one you are looking for. So you're talking about the non-faulty cars. So now, but you remember your universal set or the sample space is you are talking about all the cars purchased. all the cars bought. So that's what you are looking at. So now to calculate those ones, so the probability of your success, that is those ones will not develop fault, is the number of sets, that is how many of them do we have over the total number of the cars bought. So the number that will not develop fault is 2,500. That is the required outcome or the desired outcome. Then the 3,000, which one is 3,000? 3,000 is the total number of cars bought. So now that gives you the universal set, 3,000. So when you divide this will give you 25 over 30. And if you divide further, this will give us 5 over 6. So that's what we have. So the probability of not developing fault will now give us 5 over 6. So that's what we have. So what we have here is 5 over 6. There are important statements we like to make at this point. If you are sure that an event must happen, if an event must happen, so we're talking about probability of sure event that this thing must happen, the probability is equals to 1. Okay? Then, if you talk about the probability, if you are sure that something will not happen, so probability of something not happening, if you are sure that something must not happen, the probability is equals to 0. So in general, probability, any probability you're calculating will lie from 0 to 1. So it will be in this range. So what does it mean? Whenever you are doing a calculation in probability, it will not be less than 0. It must not be greater than 1. So it will be from 0 to 1. If you look at the previous examples we did, for instance, in this last one, we talked about the probability of the car not being faulty. We got it to be what? 5 over 6. You see that this is less than 1. So it still falls inside this interval. The other one we calculated probability, we got 1 over 20. So you see 1 over 20 still falls in that interval because this will give us 0.05. So this will give us 0.05, which is still in this interval. So once you calculate probability, maybe you calculated a probability and you got 1.2. You know that what you did is completely wrong. Or you got something like minus 0.5. You know it is wrong. Then you can also talk about probability of 50-50. That's what you call 50-50. For instance, 50-50 in the sense that you are not sure whether it will happen or it will not happen. So you are like in between. So such probabilities will give you half. So the probability of that, you have it to be what? Half. You say that this is a 50-50 if you are not sure that it will happen. Then, having said that, another thing that we also need to generalize. If maybe you have probability of a set, this is S, this is probability of S happening. So this is the probability of S happening. Then we can talk about probability of not S happening. How do you get that? If you are given the probability of S happening, this is probability of S happening. What will be the probability of S not happening? So the probability of S not happening, maybe we denote it by Q, for instance. So let's see that this is the probability of S not happening. So let's define it appropriately. So let's look at this as, let's say S happening. Okay, and let's use Q of S to be S not happening. So now, if the probability of S happening is given, so supposing this one is given to you, then you are now told to find the probability of S not happening. So this is what you are told to find. How do you find it? It becomes Q not happening is equals to 1 minus the probability of that thing happening. Okay, so now we generalize this. In the subsequent video now, we'll look at more on that issue. But this is actually what we have. But we'll look at it properly and give examples concerning that.